Welcome to the Explainer. Look, the world of first-person view, or FPV drones, can be totally overwhelming, right? Well, today we are going to completely demystify it. We're not just going to toss a bunch of random parts at you. Instead, we're building a comprehensive, highly capable 4-inch FPV setup completely from scratch. We'll cover the drone itself, the radio, and the headset. So if you've ever felt intimidated by the sheer number of components out there, you are absolutely in the right place.
So the crucial point here is that we aren't just soldering parts together and crossing our fingers. It's a harsh reality, but most failed first builds aren't actually caused by bad soldering at all. They're caused by incompatible components. To beat that, we're going to approach this by engineering an interconnected ecosystem. Every single part we choose today will speak the exact same language, rely on the same power constraints, and work in total harmony to keep you from falling into that exact beginner pitfall.
Here is the agenda for how we're going to tackle this. First, anatomy of FPV systems. Second, the 4-inch drone base. Third, the radio control link. Fourth, choosing your FPV headset. Fifth, uniting the video system. And finally, number 6, bench testing and safety.
Okay, let's dive right into this. Section 1, Anatomy of FPV Systems. It actually really helps to think of an FPV drone kind of like a biological organism. First up, you've got the mechanical system, which is your carbon fiber frame and hardware, basically the drone skeleton. Next is the power system, the LiPo battery, the motors, the speed controllers. You can think of this as the heart, right? It's pushing all that raw energy through the craft. Then there's the flight control system acting as the brain, and finally the FPV video system, which acts as the eyes. If any of these systems fail, or if they just don't play nicely together, well, the organism simply can't fly. Let's zoom in on that flight control system for a second. The flight controller, or FC, is quite literally the brain of the whole operation. It's this incredibly smart little circuit board that processes data from onboard gyroscopes, and then it mixes that with the stick commands you're sending up from the ground. For this kind of build, that brain will likely be running beta flight firmware. It's constantly processing all the complex physics of flying. We're talking thousands of times per second, just to keep your quadcopter stable and responsive. But, a brain can't do much without muscle, and that's exactly where the electronic speed controller, or ESC, comes into play. The ESC takes those calculated signals from the flight controller and translates them into very precise bursts of electrical current to spin your motors. On modern builds like ours, you'll typically see a 4-in-1 ESC board tucked directly underneath the flight controller in a central stack. It just keeps the wiring incredibly clean. Moving right along to Section 2, the 4-inch drone base. We're focusing on a 4-inch platform today because it really hits the ultimate sweet spot. We're using a proven blueprint here called Pathway A. Check this out. We start with the ImpulseRC 4v5 frame kit, which is super well regarded for its low vibration. We pair that up with iFlight Zing 2 1404 motors at 3800 kV. The physical size and the speed of those motors are just a flawless match for spinning HQ Prop 4-inch tri-blade propellers. And to run the whole show, the Blitz Mini F7 stack. Using a blueprint like this completely eliminates the guesswork. It just works. All right, Section 3, the radio control link. Now, what's really interesting about this is how one technology has completely taken over the hobby. I'm talking about Express LRS, or ELRS. If you are building a drone today, ELRS on the 2.4 gigahertz frequency is the absolute gold standard. It gives you incredible range, signal strength that can punch right through walls, and ultra-low latency, meaning the millisecond you move a stick on a controller, like the Radio Master Pocket, for example, the drone reacts instantly. Okay, listen up, because this is a massive beginner trap. When you go to solder your tiny ELRS receiver to the flight controller, you have to cross the communication wires. The transmit wire, the TX, from the receiver absolutely must go to the receive pad, the RX on the flight controller, and vice versa. If you go TX to TX and RX to RX, the boards will power on, sure, but they'll basically just be shouting at each other without listening. Crossing those wires is a must for two-way communication. That brings us to Section 4, choosing your FPV headset. This is probably the biggest decision you're going to make in FPV today, analog versus digital. Analog systems like the SkyZone 04X Pro are incredibly reliable. They have zero variable latency, and the parts you put on the drone are super cheap and lightweight. The catch: the video feed looks kind of like a fuzzy VHS tape from the 90s. Digital FPV, on the other hand, blasts a high-definition 1080p feed that literally puts you right in the cockpit with stunning clarity. But naturally, the gear is quite a bit more expensive. If you do go the digital route, you are buying into a locked ecosystem.
It basically breaks down into three heavy hitters. You've got DJI's O4 system, which is the undisputed king of cinematic image quality. Then there's HD0, built for pure racing, because it locks in an ultra-low 14 millisecond latency with zero variable lag. And finally, Walk Snail, which offers this really flexible middle ground with lightweight parts that work on everything from tiny indoor hoops up to our 4-inch build. Just remember, your digital goggles will only talk to video transmitters from that exact same brand. No mixing and matching here. But honestly, tech specs on a screen mean absolutely nothing if the goggles don't fit your face comfortably. When you're choosing a headset, you need to check the interpupillary distance, or IPD adjustments, just to make sure the screens actually align with your eyes. If you wear glasses, definitely look for models with built-in diopter focus wheels. And getting a proper foam fit for a perfect light seal against your face, that is absolutely critical to feeling totally immersed in the flight.
And this brilliantly illustrates our next topic, Section 5, Uniting the Video System.
Okay, inside the drone, your camera feeds video directly into a video transmitter, or VTX. I need you to burn this golden rule into your memory. Never, ever power your VTX without an antenna securely attached. Seriously, don't do it. If you plug in a battery and that transmitter has nowhere to send its radio frequency energy, that energy just bounces right back into the board as heat. It will literally fry your brand new expensive component in seconds. Always, always check your antennas.
Almost ready to fly. Section 6, Bench Testing and Safety.
Plugging in that battery for the very first time is honestly a nail-biting moment. To protect all the money and time you just invested, you absolutely must use a smoke stopper, like the VIF Fly Short Saver V2. It's just a cheap little gadget that sits between your battery and your drone. If there's a short circuit anywhere, maybe a tiny rogue blob of solder, the smoke stopper instantly kills the power before your electronics can burn up and release the dreaded magic smoke. Once you get a clean power cycle with the stopper, you just plug the drone into Betaflight to verify your radio sticks are actually moving the right channels.
By treating your 4-inch drone as one interconnected ecosystem, perfectly matching the frame to the motors, crossing those receiver wires, and pairing the right VTX to your goggles, you're setting yourself up for a totally smooth, safe build. So, looking at everything we've put together in this explainer today, I want to leave you with this. What kind of 4-inch FPV pilot are you going to be? Are you building this to rip some aggressive freestyle, capture smooth cinematic shots, or are you aiming for long-range exploration? The knowledge is yours now. Go grab your parts, and happy flying.